Section 2.6, Inverse Functions and Relations. The essential question is, how can we find the inverse of functions and determine if a function is one-to-one? So we start off with an application. The speed limit for driving in a school zone is 20 miles per hour. That seems so slow if you're riding in a car. But have you ever wondered how quickly you could come to a complete stop going that speed, even if you have super quick reflexes? It would take you over 13 feet. The speed of a vehicle S and the stopping distance D are related by the function S of D equals square root of 30D. Fill in the table of values for S of D, round to the nearest whole number, then graph S of D and answer the questions. So if D is 25, we would do the square root of 30 times 25. It gives me 27. I think they said round to the nearest whole number, so that would be 27. If D is 50, the second square root 30 times 50 gives us 39. If D is 100, square root of 30 times 100 is 55. D is 200. So 200 times 30 is 77. And then D is 300. So 30 times 300, the square root is 95. So we're going to plot these points on our graph. So 25 on X, 27 on Y. So it's there. We have order pair 50, 39. Let me count that again. All right, 50 and 39. So counting by 5s, 5, 10, 15, 20, 35, 40. So it's right there. All right, if the distance is 100, the speed is 55. So that would be up here, right there. Distance 200 is a speed of 77. And then a distance of 300 gives a speed of 95. So that would be there. All right, and then we're going to connect these. It's going to be like a little bit of a curve. Now we can see that it would continue down and continue this way. If you were a police officer investigating an accident, you would be able to measure the length of the skid marks on the road and then approximate the speed of the driver. The driver swears he was sure he was going under 60 miles per hour. The tire marks show a pattern for 150 feet. Is the driver's sense of his speed accurate? Justify your answer. Okay, so at 150 feet, that would be here, so we would go up to here, and then measuring back this way, 55, 60, 65, looks like it's about 67. So this looks like the speed was 67 miles per hour. And he was sure he was under 60, so no, he's not accurate. Use your answers in the problem to make a graph of stopping distance as a function of speed. Okay, so if stopping distance is a function of speed, we need to go back up here, and basically we need to have, instead of having, instead of distance being the independent variable like it was in this up here, we need to flip that and make speed the independent variable. So in our table, typically we have the X column and the Y column. This time we want to flip it around. So we want to measure distance as a function of speed. So we want to use the same table, but we want to do S for the independent, and that's miles per hour, and we want to do distance in feet for dependent. So we're going to use the same information, but we're going to rearrange it. So 2725, 3950, 55 100, 77 200, and 95 300. So let's plot this graph. Let's find these points. So speed now is on the x-axis, and we want 27. Be like right there, and 25 on the y. So that's here. 39 on the x. Be there, and then 50 on y. And now we need 55 on x and 100 on y. 77 on x, so 50, 60, 70. So 77 on x and 200 on y. And 95 on x and 300 on y. All right, so that's going to be here. And let's connect this one. It's another curve. All right, so they're asking us, how are the two graphs related? They're similar, but they're flipped. This one is, you could say that one is like a concave down shape, or it's like a parabola that's opening down. This one is like a concave up shape. So they're similar, but they're reversed. Okay, and then down here we need to define some terminology. Inverse relations. Okay, so that's what we just saw here. This is when the elements, the ordered pairs, the x, y of a relation are switched around. So that's what we consider an inverse. So all the original x's became y's, all the original y's became x's. The vertical line test is a test to see if a graph is a function. So we talked about that a little earlier. We also have a horizontal line test. This one tests to see if a graph's inverse is a function. One-to-one is when a relation and its inverse are both functions. Okay, so go ahead and fill that in. Let's look at some examples. All right, example 1. In part A, are the following inverses of each other. In order for two relations to be inverses of each other, the x's in one relation should be the y's in the other, and the y's in one should be the x's in the other. So if you look at each of these as ordered pairs, you can see that the x's and the y's have been reversed. In each line, they've just traded places. That's all they've done. So this one is yes. In part B, so I'm getting used to this. Okay, so in part B, if I look at the ordered pairs here, I see x is -1, y is 5. I come over here and I don't see I need to have -1 in my output column somewhere with a 5 in the input column. Well, I see the 5 in the input column, but it's got a different output. So that -1, 5 is not represented over here. So every ordered pair in the original, we should be able to find in the second table, but reversed, and that's not happening. So this one is no. Example 2, are the following one-to-one? So to determine if they're one-to-one, that means that both the original function and its inverses would be functions, or excuse me, both the original relation and the inverse would be functions. So if you remember, we did problems similar to this when we were trying to determine if we had a function, and the way we did that was we would check to see in a function, each x is matched with exactly one y value. So if we had, like, we've got -1 matched to 5, but if we found another -1 matched to a different number, then that would not have been a function. Functions are one-to-one if you can say the same thing in the opposite direction. So it has to be a function like this is. Each x is matched with exactly one y, so we've got that. We don't have any repeated x's over here. But if you look at the output column, each y has to be matched with exactly one x in order for it to be one-to-one. And here you see 4 is matched with 1, but you come down a couple of lines and you find 4 again is now being matched with 3. So that is a problem. So this is not one-to-one. So you can think of a one-to-one function as being a function forward and backwards. So if you did it over here, all the y's should be matched with exactly one x. In part B, so I'm looking at the x's. Each x is matched with one y. I do not see a repeated x in my x column. And then when I look at the y column, each y has to be matched with exactly one x. So 5 is with -3, 9 to -2, 2 is -1, 11 is matched with 0. I do not see a y showing up more than one time in this table being matched with two different numbers. So this one is one-to-one, because each x is matched with exactly one y, and each y is matched with exactly one x. So I remember as a student, it took me a while to really get what I was checking for here. So if that pertains to you, please just, come talk to me. Example 2. Graph y equal x squared. All right, so I'm going to do a table of values. I'm going to put in for my x's, I'm going to put in -2, -1, 0, 1, 2. All right, so if I put in -2 for x and square, I get 4. Putting in -1 gives me a +1. If x is 0, y is 0, and then here I'm going to get 1, 4 again. So I'm going to plot these points. -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And I can connect those, and I'm not surprised to see that it forms a parabola shape. Over here, I'm asked to graph the inverse. Okay, so now I'm going to flip the x and the y around. So the original x's, now I'm going to put in the y column. And all of my original y's, I'm going to put in the x column. And I'm going to plot those points. So I'm going to 4, -2. Okay, that should be a +1 there. I apologize about that, and I don't have any white out. It should just be +1. So I've got 4, -2, 1, -1, 0, 0, 1, 1, and 4, 2. And now I have a U shape, but it's around the x-axis instead of around the y-axis. So part A asks, is the inverse a function? Well, in order for the inverse to be a function, the graph would need to pass the vertical line test. I can see if I draw a vertical line through this, it's going to touch the graph in more than one place. So it's not. The inverse is not a function. Part B is the function 1 to 1. Well, if I look at the inverse, I do not have a function when I look at the inverse because I've got 4 matched with -2 and also 4 matched with +2. So no, it's not. Example 3. I need to graph y equal x plus 2. So I don't really need to use a table of values to do this, but I like having it as a reference, so I'm going to go ahead and put in, I'm going to put it -1, 0, and 1. So if x is -1, y would be 1. If x is 0, y is 2, and if x is 1, y is 3. So I got -1, 1, 0, 2, and 1, 3. And I need a straight edge. I've got a fly guy in the Frankenfly book here for my straight edge. Okay, then I have to graph the inverse. So graphing the inverse is really easy. You just flip the x's and the y's around and graph that. So now it's going to be 1, -1, 2, 0, 3, 1. And a straight edge for that one. That's not a perfect straight edge. But. Okay, so my graph looks similar to the first one. Is the inverse a function? Well, if I look at my table of values over here, each x was matched with exactly 1 y, so I can say yes. And I can also look at, I could do the vertical line test on this graph. Is the function 1 to 1? So the original function, yes, because each x was matched with exactly 1 y, and each y was matched with exactly 1 x. I never had a repeated y value in this table, so I can say yes. And I also noticed that the original function not only passed the vertical line test, but it also passed the horizontal line test, which works the same way. If you could draw a horizontal line anywhere on this graph and have it touch your line more than one time, then you would not have a 1-to-1 function. So this one is 1-to-1 because that doesn't happen. It passes the horizontal line test. But back at example 2, you can see how in example 2, that one would not pass the horizontal line test, so that's not a 1-to-1 function. And that's why the inverse was not a function. It fails the vertical line test. Okay, so here's some for you to try. Draw the graph of the inverse function for each of the functions shown below on the same coordinate plane. So I would like for you to pause the video. I want you to graph the, what you can do is you can look very carefully at this and you should be able to identify some points on here. So in part A, I'll help you out. I can see that the ordered pair, I can do a table of values for that function. I can see that 0, 2 is on there. And then if I come back here, I've got a point. 1, 2, 3, 4, 5, 6. So -6, 0. And then over here, there's one that I can read right there. It touches right there at the corner of the grid. And that would be 6 on X and 4 on Y. Okay, so use this to get some points for your inverse graph. And pause the video while you work out parts A, B, and C, and then you can come back and check your answer.